All right, we're going to point out three ways that the pulse hot runner controller saves energy, electricity specifically, peak kilowatt demand, which is expensive. That's what you pay for on your electric bill, are the peaks, and that is the highest rate on the bill. And within a facility to proactively minimize the peak amp draw, peak kilowatt demand on a location gives you more freedom in your facility to move projects around and so forth. So it's going to save you money on your electric bill. It's going to give you freedom to control how much amp draw you have in that area of your shop, and proactively do this all for you. Just preset three things that happen. The first I'll explain is for startup. So if I go to my system tab, there is this feature called Even Soak. And then back on my main screen, you can see here that I have these different groups. And you can see here I can change that up to 6 groups. So 1, 2, 3, 4, 5, 6. What that's going to do is automatically start group 1 from 0 to set point. You're going to see it go to 100% power. All the zones in group 1 are going to turn on. And then it's going to get to set point, and then it will go over to group 2, 0 to set point, group 3, 0 to set point, and so forth. What that does is it ensures you're not starting the tool all at one time. You're not maxing out the amperage, the amp draw on that tool at the beginning. And unfortunately, in the traditional modular control market, a lot of times, because it's just time consuming, people just walk up and start flipping all these modules on. They're all turned on at one time. So you can, do the math and limit that peak amp draw right up front by sequentially starting your tool, which of course is also best practice for protecting your tool. So protecting it from tool wear, preventing leaks, and so forth. So at startup, Even Soak is a way you can manage your peak amp draw. The second thing I'm going to show you is over here. So I went to my zones and I went to set point limits, and you can see that I've got this governed down to 60%. And you can set that to whatever you'd like, but what that means is when the tool is ramping up, when the tool is in production, it'll never go over 60% power on that zone. So again, another opportunity to limit the amount of amperage that you have on the tool and the kilowatt demand. It will of course take longer to get up to set point. That's logical. But this gives you an opportunity to especially run a little bit of a larger tool on a lower amp service, as you sometimes may have to. We have molders that we're amazed. I mean, they typically blow circuits on certain tools and they know it. They put our pulse controller on it, use the governor, and voila, they're up and running. And then the third way that we save energy and reduce peak kilowatt demand is what we call waterfall technology. And what that means is when these zones are all running in production, so you can see here I've got a 12 zone application, we will limit this so that out of 12 zones, you're going to break the tool into 3. So 4, 4, and 4. We're never going to have those overlap when this thing's at temperature. Especially, if it's at 33% power or less, those zones just simply will not overlap. And then we do that in our algorithm. It's part of our secret as to how we do that. We basically stagger when zones turn on and off. And that allows us to minimize the peak amperage on the tool, and significantly reduces your energy expense. Also improves the processability of that tool. It makes running a tool a lot easier because of the consistency. It's the fact that we're not jumping up and down on amp draw and turning our heaters way up and then way down and way up and way down. And we can actually see that in our graph that we've gone through and measured one controller type versus our pulse controller type, and it's a significant difference. The volatility in the heaters is much less, much more stable temperature control. So 3 ways we save on electricity and energy is the even soak, our max percent power, and waterfall technology.